All right. Thank you all for joining this inaugural Project Harrison webinar today. I'd first like to thank Dr. Padma Priya, who's on the call with us. She's a professor at AMET and an artificial intelligence specialist. And I just want to thank her for helping coordinate this session. I also want to thank Dr. Captain Nikolay Bedzev at Nautic Blue, Yanis Privilos of Product Compass, and Aurora Thomas, who is a postgraduate student in maritime cybersecurity, for being on the steering committee for this and future sessions. So now more than ever, it's essential for nautical science, marine engineering, and data science communities to bridge gaps in understanding between their respective fields. Whether you're new to the domain or a seasoned professional, the goal of this and future sessions is to foster a practical understanding of maritime informatics, learn about open source, and perhaps gain some inspiration for your own projects. Today, we'll be exploring Uber's H3 Geospatial Index with Mohammad Jabari, a senior data manager at Wärtsilä. Mohammad is formally trained in computer engineering and has been deeply involved in maritime-related data science for over a decade. I'm thrilled that he offered to speak and looking forward to this subject matter. Before we begin, I'll briefly touch on the meeting schedule. Mohammad will speak for about 10 to 20 minutes. We'll do a 10-minute Q&A afterwards, and then we'll wrap up. We have a dead stop at minute 45. For the sake of keeping this organized, post your questions in chat, and I will ask the questions after the presentation is finished. Upvote the questions you want asked first. And I also will post a working demo of Uber's H3 as a link in the comments about halfway through Mohammed's demo. Thanks again for everyone who joined this call, and I will turn it over to Mohammad. Yeah.
Jordan, thank you so much. Hello, everyone. Appreciate your time, and I'm happy here. Let me share my screen and see what we have here. So today we want to discuss about the geospatial data processing with a fancy name, 1,000 times faster than regular or traditional calculations, especially in AIS data processing and especially in maritime industry. So let's start from the who am I? My name is Mohammad, and actually it's around a decade I'm especially working in data engineering, data science projects, and it's a few years I dedicate myself for the maritime industry with a different project, with a different organizations, and with a different perspective of this industry, from the regulatory to port management to port optimization to fleet optimization, and actually from the A to Z of these industry, I'm involving that. I'm more than happy to connect with you. Please scan the QR code and let's connect together in LinkedIn, and or search my name in the LinkedIn. My first name is Mohammad and my last name is Jabari. So let's start from the one very clear and specific questions. How we can find a point or an area in Earth? This is very simple and very straightforward questions. Hey Mohammad, if you want to address one point or one specific location in the Earth, what do you prefer? As you know better than me, it's very obvious. We will use latitude and longitude for referencing one point. If we want to address an area, we come up with the idea of the resolution. Hey Mohammad, when you are saying area, do you mean 1 meter, 10 meters, 100 meters, 1 kilometers? What do you mean exactly? So we will talk later about that. Let's talk about the latitude and longitude. As you know better than me, for addressing one point in, for example, I'm based on Vancouver. My location is 49 minus 23 in latitude and longitude systems. So what's the, if we want to dive into the precisions, after the decimal, actually the decimal point is our precision systems. So in that case, we can address into two different systems, decimal or degree minutes seconds. In a different tools and perspective, we are using different one. But for now, let's talk about the decimal point. So latitude, I'm trying to review that. Latitude and longitude. And if we want to have the precision of that, precision of location, we gonna use the different decimal points. It's easy and very straightforward. Back to the resolution topic, when we are talking about the area, if we keep the resolution in 4-digit, actually we are talking about the something around 10 meters. 10 meters from the 10 meters between the gap, actually. Or if you go with a 2-digit, it's something between 1 kilometers from the, actually, or point is something between these 1 kilometers. So this is the a chart which will list that here. So let's imagine for maritime industry, we can go with a less resolution or less precisions. But for now, let's keep it for something around 4-digit resolution, around 11 meters or 10 meters as an example. So Mohammad, you are telling us 4 decimal places, it's around 10 meters. How many points in all around the world we have in Earth? We have, after calculation, you can see the calculation below, we have 6.5 almost trillions points in 4 decimal precisions in all around the Earth. So with something around 11 meters apart, depending to the latitude and longitude, because the curve of Earth is not every place is the same. And yeah, I'm trying to simplify everything here. So with these assumptions, after calculation of the land or water, because we are talking about the maritime, so let's remove the land points and keep the water points. So in that case, around something 6 trillions, we will keep 4.6. How we can calculate that? It's a ratio of the 70 to 30%. Here you can see that 70 to 30% of land or water in the Earth. So we come up with a 4.6 trillion point. If we want to talk about the AIS in maritime industry, we are facing with 4.6 trillion latitude and longitude related to AIS data. Okay. What's the use case of these points? What we can use them? Okay, as you know better than me, you are busy with these projects such as a vessel traffic monitoring or anomaly detection or port terminal optimization or port call optimization or calculating the ETA or just-in-time arrival, or in cybersecurity of the AIS, maybe AIS spoofing or GNSS and cybersecurity in maritime domain, or maybe talking about the ocean and environmental, or maybe fishing, zone monitoring or illegal act of the fishing and those things. For these purposes, for these use cases, we can, instead of use points, we can use the area instead of the points. In that case, we can actually summarize each point into one area. It's really effective, and it's really, when I'm saying effective, I'm talking about the resources in matter of the time of calculation, time of data processing, time of the complexity, and all from this perspective, we are saving a lot of resources. Resources is money, time, and so on. So we talk about the points, then we talk about the area. So we have a lot of advantage in comparing points to area. Let's keep the area. Hey, Mohammed, which area do you mean? Are you talking about circle? Are you talking about the square? Or which shape you are talking about that? After there's an interesting chart. Which area you can cover almost all around the world without missing any places? It's a really interesting notebook. If you want, let me know. I will share it with you. With a hexagon, actually, we can cover all around the world with a very good precision. So, let's talk about the, okay, we come up from the point to area to hexagon. In perspective of implementation, let's talk about one of the good, or let me say that, fantastic libraries, very fast, very follow the best practice of the market and industry from the Uber. Actually, it's a global grid system for indexing each part of the world with a different resolution in hexagon grid. Developed by Uber, it's actually when you are getting Uber, you are using this library in behind the scene. It's developed in Python, and you can use the Python as well. I have an image here. For example, let's talk about the Black Sea as an example. I cover Black Sea with a different hexagon here. So in that case, with almost 1 or 2 hexagon, I'm covering all the Black Sea. Or in 122 hexagon, I can cover all around the world. So if I want to just show a heat map of the world, just I'm facing with 122 points. I'm simplified points or hexagons. So that I have another example here with a different resolutions. For example, here, imagine a road from the Istanbul. I have the different hexagons here, different resolutions of hexagons here. And this is the road from these 2 points, from A to B. So in that case, I'm facing with a actually much less than regular AIS data points. So my calculation is very fast. I can maneuver on many other different algorithms in data science or in any perspective which I want to jump in that, or from visualization perspective, or from the calculation or algorithm usage. So I like to mention about the resolution here again. If you remember, we talked about latitude longitude resolution. Resolution, it was around 10 meters something. So here we have a list of resolutions from 0 to 15. From the 0 is we divided Earth into 110 hexagons, and based on our requirement, we are changing these resolutions here. Now let's compare these two systems into Black Sea. I use the Black Sea as an example for we have tangible data for seeing exactly what we are talking. So Black Sea area is something around 436 kilometers, 1,000 kilometers, and with the H3 resolutions, I'm talking about the Uber library. It's with the resolution 9, we are facing with 4.15 million. But when we are talking about the latitude and longitude, we are facing with 4.6 billion with a B. It's actually, if we want to compare these two different grid systems together, we are facing with 1 point from the H3 to 130 point from the GPS point. So it's actually around 99.9% decreasing the calculation. I'm oversimplified, decreasing the calculations, but imagine we are facing with the industrial solutions, industrial data. It's really huge and significant impact on our processing systems and our ability. Let me come up with a conclusion and let's put everything together here. So again, with the 4 point, with the latitude and longitude, we are facing with 0.6 billion with a B, with the H3. Again, this is a Black Sea example. 4 million. If we want to calculate these data in with a CPU, it's around with the GPS data, I mean latitude longitude, is something between 10 to 30 minutes, comparing to 10 seconds with the H3 with the Uber library. In matter of the GPU, it's really significant, comparing 1 minute to less than 1 second. And actually, if we want to comparing to the data storage, we are facing with a 30 gigabyte of data to 30 megabyte of data if we want to store these data in places. So in general, after this calculation, we come up with something around 1,000 times faster calculation than regular using latitude and longitude. And we highly recommend that based on the project to, instead of using the latitude and longitude, hey, let's convert your data and use the H3 for your calculations. I'm more than happy to have if you have any comment, concern, questions, I'm more than happy to hear that. Yeah, thank you.
Thank you, Mohammed. So we have about 10 minutes. If anyone wants to ask any questions, please do so now.
If you have any questions about the AIS data, about how to use these Python library, or how to use, maybe you are facing with a pure GPS latitude longitude data, yeah, let's have a discussion about that.
I'll ask the first question, Mohammed. So this is an Uber package. I presume they created it for their ride-sharing platform. Do you know what specific use cases that this H3, besides speed, like how is it employed at Uber? Do you know? So
I cannot say that a specific answer, but we can think together loudly. Yeah, in general speaking, it's based on the when we are talking about the speed, actually we are talking about the resources. The first vision and mission of each company is to minimizing the resource usage. With these cases, actually we are not only the speed, I'm trying to focus on the resources. Yeah, actually imagine about the how we are saving data from the user perspective, because he or she is loading the app. In that case, just we are passing a few ID of these hexagons instead of latitude and longitude for these routing and calculation. Yeah, this is one of these idea and come up my mind, yeah, right now.
Thank you. Go ahead, Roberto.
Hi, how are you today? Yeah, I was reading about it. A very, very cool project that Uber did it. I think it's not only for the data management. Mohammed mentioned that H3 is being used, but also Uber used it to calculate the rate, basically to know how during this peak hours how much it will be the rate on a specific driver, right? And in addition to that, they are saving the rate of cancellations, basically they reduce the rate of cancellation of those cars that being canceled to the minimum possible. So of course they still have some cancellation rate, but they reduce it basically at the rate of 90% of cancellation not being canceled, because of the neighborhood proximity between all the neighbors that they have around a specific area. So they use H3 as a methodology to help them to reduce cost, cancellation rates, and also increase or decrease the money that the customer paid during the transaction. Pretty cool project, by the way. So I think for the maritime environment, it will help them in the same way or on more like saving fuel and things like that.
Thank you, Roberto.
You're welcome.
Yeah, thank you. Go ahead, Ara. So Ara says, as long as I can understand those both systems has their own pros and cons in terms of use cases. GPS is better for precision tracking, navigation, and routing, while H3 is better for heat maps, demand supply aggregation, and spatial joins. Is that correct, Mohammed?
So it depends, because in H3 actually we have the precisions as well. It's depend on to the resolutions, but the good point is that in H3 over there you have the resolutions, so you can drill down or roll up based on your solutions. So in that case you can use a different resolutions for saving resources. But with the latitude and longitude, you are not facing these roll up or drill down data. Just by removing the tool you have is just removing the precisions. But over there, actually, you are changing the data type. I'm talking about the technical perspective, changing the data type, or but it's not reversible procedures. But in H3, it's a reversible procedure as well. Hope I address your concerns. Thank you.
Yeah, if I may say, as I was playing with it last night, one of the use cases I found was in the ECA zone, the emission control areas. You can map whether vessels are at their economical speed or not, whether they're complying with ECA speed, and it actually would heat map vessels that were in compliance and out of compliance. I would imagine over time you could develop policy around this or something like that.
Let me comment on your experience. Actually, my question is that what's the use case of latitude and longitude? Hey, Mohammed, it's unlimited, and we do not have any. we cannot list it. It's similar system for that, similar system for latitude and longitude, but with a reversible or adjustable resolutions. So unlimited use cases, and we can list it. It's unlimited listed, yeah.
Liam at Edith Moore has a question. It is challenging to translate from, is it challenging to translate from GPS to H3? If I've got a lot of GPS data and I want to convert it to H3 for further processing or vice versa, how difficult is that?
That's a really good question. So the good part of these library in a production environment is very fast and very optimum converting data. Imagine you can store your data latitude and longitude slash these ID of Hexagon as well. It's really fast when you call the function to convert the latitude longitude to the Hexagon, or converting Hexagon to the latitude longitude. It's totally reversible, and H3 can handle that easily. Thank you.
Thank you. The next question is, do you sometimes end up with one hexagon crossing over 2 latitude and longitudes?
Okay, that again, that's another good question. It's required to have a workshop together and walk through these questions. But the short answer is yes. It's depend to the resolutions, and if we are facing with we need a more precision to find out these overlapping, we can we need to change the resolution to more precision. In that case, it will solve easily. Yeah, but in a workshop, we can easily implement it. It's a really good example.
Thank you. Next question is, what were the key technical and operational challenges in adapting general purpose AI models to handle the unique constraints of real-time maritime data, such as variable sensor quality, communication latency, and regulatory compliance? And how did your team address them?
So if I understand your question clearly, when you are saying adopting general purpose of AI model, if you tell me more about your question, I can address it better if you want. This is my question. If you want, or I can follow up what you have here.
I just want to add in also that, and correct me if I'm wrong, Mohammed, but this is an open source package, so
yes,
freely available. It's on, I saw that it's on GitHub, and they also have their own website. So I think it's h3geo.org. So anyone who's somewhat proficient in Python can go to GitHub. They can download the repository and start using it. When I send the recording with this session, I will send a link to a notebook or GitHub repo that has a quick start for H3 for anyone who's wishing to use it. Okay, any more final questions? I want to just address the students in here. If anyone has any questions about what it's like to be a data scientist or anything like that, I'll give you a few seconds to raise your hand or ask the question. I'd encourage you to ask if you can.
Or you can find me in LinkedIn and ask your questions. Yeah, if you come up with any questions or idea later, yeah, I'm more than happy to connect with you.
All right, so this will be the last question. Describe your experience with S57 or S100, the electronic nautical chart format.
Yeah, that's a really good question. And actually, one of our open project is related to S100. But accept my apology, because we have a NDA here. I cannot share the detail of the project, but this is one of our open projects here, unfortunately, because we are working on one of the ports around the world. They come up with a EOC award competitions, and we are busy with that. And yeah, I can share that. Yes, we are working with that, but not in the details, unfortunately.
All right, perfect. Well, thank you, Mohammed. That's a good clue right there.
Sorry about that.
That's a big clue. Thank you. All right. Well, we've run out of time. Just thank you so much, Mohammed. This is great. I really appreciate it. I love when I hear new things, because I hadn't heard about this before myself. So this is really cool. And I'm looking forward to playing with it. I'm already seeing like at least a half a dozen use cases for this. So thank you. All right, to everyone in the meeting, thank you for coming. I'll send you all a recording link in due course. Our next session is tentatively scheduled for June 6th, but may change. I will update all of you. And I want to thank you all for attending this webinar. And thank you, Dr. Padma Priya, for helping coordinate. And thank you, Mohammed. All right. Nice to see all of you. And maybe I'll see you all at the next session. Take care.